Can anybody tell me how you are going to judge that? How you are going to say that the given series is convergent or divergent? ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರ್ತದೆ? ಲಿಮಿಟ್ ಆಫ್ ವಾಟ್? ಲಿಮಿಟ್ ಆಫ್ ವಾಟ್? ನಾಟ್ nth ಟರ್ಮ್. ಲಿಮಿಟ್ ಆಫ್ ವಾಟ್? ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಯಾವುದಾದ್ರು ಡೆಫಿನೇಷನ್ ನಾವು ಮಾಡಿದ್ವಿ ಫಸ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಕ್ಲಾಸಸ್. ಎಸ್, ವೆರಿ ಗುಡ್, ವೆರಿ ಗುಡ್, ವೆರಿ ಗುಡ್. ಸೊ ಪಾರ್ಷಿಯಲ್ ಸಮ್, nth ಪಾರ್ಷಿಯಲ್ ಸಮ್ದು ಲಿಮಿಟು ಫೈನೈಟ್ ಇತ್ತಂದರೆ ನಾವೇನಂತ ಹೇಳ್ಬೋದು? ಕಾನ್ವರ್ಜೆಂಟ್ ಅಂತ ಹೇಳ್ಬೋದು, ರೈಟ್? ಸೊ ಸೇಮ್ ಥಿಂಗ್ ಓವರ್ ಹಿಯರ್. we need to construct a nth partial sum for this, what I can say, this given series summation over n is equals to 1 to infinity un. So after that we can check that whether if the nth partial sum, sequence of nth partial sum convergent ittandre summation un convergent irtade. And summation un convergent aitandre obviously ಇಲ್ಲಿ ಹೆಂಗೆ ಇಂಪ್ರಾಪರ್ ಇಂಟಿಗ್ರಲ್ ಆಲ್ಸೋ ಕಾನ್ವರ್ಜೆಂಟು ಇರ್ತದೆ ಅಂತ ಹೇಳ್ಬೇಕು ಈಗ ನಾವು. ಅಥವಾ ವೈಸ್ ವರ್ಸ, ಇದನ್ನು ಕಾನ್ವರ್ಜೆಂಟ್ ಅಂತ ತಗೋಬೋದು ನಾವು ಇಂಪ್ರಾಪರ್ ಇಂಟಿಗ್ರಲ್ನ. ಸಮೇಷನ್ ಆಫ್ n is equals to 1 to infinity un ಕಾನ್ವರ್ಜೆಂಟ್ ಅಂತ ಹೇಳ್ಬೋದು. ಅಥವಾ ದಿಸ್ ಇಂಪ್ರಾಪರ್ ಇಂಟಿಗ್ರಲ್ ಡೈವರ್ಜೆಂಟ್ ಅಂತ ತಗೊಂಡು ನಾವೇನಂತ ಪ್ರೂವ್ ಮಾಡ್ಬೋದು? ಸಮೇಷನ್ ಓವರ್ n is equals to 1 to infinity un is also divergent ಅಂತ ಪ್ರೂವ್ ಮಾಡ್ಬೋದು. ಸೊ that we are going to prove here. So for that purpose we need to convert the given series in terms of what? Nth partial sum. So what they have given in the next step, let r be any positive integer. Choose a real number x such that x lies between r and r plus 1. r and r plus 1. See, you need to choose a real number r, right? You need to choose a real number r. You need to choose real number r, and how real number r for x, and how you need to choose the x value lies between r and r plus 1, right? And since f is monotonically decreasing, right? So monotonically decreasing andre eno? Can anybody tell me what is the definition of monotonically decreasing? Yes? monotonically decreasing ದೇನು? ಹೇಗಿರ್ತದೆ ಎಲಿಮೆಂಟ್ಸ್? xn plus 1 is less than an, or if you take an sequence or xn, that doesn't matter, but xn plus 1 is less than equals to xn, or I can say that an plus 1 is less than equals to an for every n value. So this is a monotonically decreasing function, or I can say that sequence. So for that we are applying that definition over here. How we have applied? See here, f of r plus 1, f of r plus 1 ಅಂದ್ರೆ ಅದರ r ದು ನೆಕ್ಸ್ಟ್ ಟರ್ಮ್ ಹೇಗಿರ್ತದೆ? f of r plus 1 is less than equals to f of x, and which is less than equals to f of r. Understand the concept? See, these two steps are very very important. ಈ ಸ್ಟೆಪ್ಸ್ ಬರೆದ್ರೆ ನೆಕ್ಸ್ಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತದೆ, ಇಲ್ಲಾಂದ್ರೆ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಂಗಿಲ್ಲ. So here we are applying monotonically decreasing function. f of r plus 1 is less than equals to f of x, which is less than equals to f of r. How we have got this inequality? According to this, got my point? r plus 1 is greater than r, right? So therefore this inequality will get. And same thing in the next step, what they have given, f of r plus 1. What do you mean by f of r plus 1? F of n, we have taken it as un, right? So in place of n, if you put r plus 1, we will get ur plus 1. r plus 1th term ಬರ್ತದಲ್ಲ, ಇಲ್ಲಿ n is equals to r plus 1 ಹಾಕಿದ್ರೆ r plus 1th term ಬರ್ತದೆ. So same thing we have done here, ur plus 1, which is less than equals to f of x, which is less than equals to f of r. So in place of r, n, if you put r, then we'll get rth term, ur. So after this step, what they have done, integrate. So we need to integrate for this inequality. We need to operate integrate. How you are going to operate integrate? Intervals, how you need to choose the intervals. See the condition over here. So this condition you need to use for the intervals of the integration. R to r plus 1, ur plus 1 into dx. So function f is concerned with x term. So therefore we need to integrate with respect to x. So dx. And which is less than equals to integration over r to r plus 1 f of x into dx, which is less than equals to r into r plus 1 ur into dx. So next step, here there are no x terms. So ur plus 1 is what? Ur plus 1 is constant term. So therefore I can take outside the integration, and in the right side part of the inequality, same thing, ur is independent of function x. So therefore we have taken outside the integration, and integration over r to r plus 1 into dx we have. So next step, what we have done, if we integrate r into r plus 1 into dx, integration over r to r plus 1 dx, what is the integration of 1? Can anybody guess me? X. So if you put x and put the intervals, what will get? R plus 1 minus r, right? So this r and this r get cancelled, only will remains with 1. So here we have taken 1, ur plus 1 into 1. So same thing for right side inequality, ur into 1 will get. So middle part as it is, middle part as it is. So I think you have up to this much. Any doubt? Any doubt? No doubt? I hope you all are understood the things. Yes? Shall I proceed? Okay. So next step, what you need to do, put r is equals to 1 to n, right? Put r is equals to 1 to n in the equation 1. Then first inequality will get u2. In place of r you need to put 1. So here we'll get 1 plus 1 u2, which is less than equals to integration over 1 to 2 f of x into dx, which is less than equals to u1. And the next inequality will get u3, which is less than equals to 2 to 3 f of x into dx, which is less than equals to u2. If you go on putting the values of r in the equation 1, last term, last inequality, what will get? Un plus 1. In place of r you need to put n, that's it. Un plus 1, which is less than equals to, right, which is less than equals to integration over n to n plus 1 f of x into dx. N to n plus 1, keep it in mind, n to n plus 1 f of x into dx, which is less than equals to un. we have. Adding all these inequalities, what are all things we have after putting the values of r? These inequalities will get, if you add all these inequalities, left side inequality what will get? u2 plus u3 plus so on plus un plus 1, because first term is started with u2. So here u2 plus u3 plus so on plus un plus 1, which is less than equals to, see here how we got the intervals. Integration over 1 to n plus 1 we got. First term is from 1 to 2 and here 2 to 3. Got my point? See here how I can get this interval. I will explain you. Integration over a to b f of x into dx, if they have given this, I can write down. How I can write down? Integration over a to c f of x into dx plus integration over c to b f of x into dx. So this method we need to use, right? I can combine. If I combine the intervals, then definitely we'll get from 1 to n plus 1. This 1 to n plus 1 will get if you combine all these terms. So right side part, if you observe right side part of the inequalities, obviously we'll get u1 plus u2 plus so on plus un, right? So if you observe these terms, so what I can represent this u1 plus u2 plus so on plus un? Can anybody tell me? Sn, very good. Why it is Sn? It is nth partial sum of the given series. Very good. Nth partial sum of the given series. So this I can write down it as Sn. And this left side part, if you observe, what is missing here? u1. Yes, u1 is missing. So therefore what I can write down? Sn plus 1 minus u1 I can write down. Right? N plus 1th partial sum minus the term u1 I can write down, which is less than equals to same thing in the middle part. So what are all things up to this much? What we have done? We have converted the given series in terms of nth partial sum, right? So here left side inequality we got in terms of sequence of n plus 1th partial sum, and in the right side part of the inequality we got nth partial sum we got. So now what I can do? Apply the limit. Apply the limit. Limit as n tends to infinity, Sn plus 1 minus u1, which is less than equals to integration over 1 to infinity will get here. Why 1 to infinity? Because we are applying limit as n tends to infinity. So therefore, if you apply n to infinity, infinity plus 1 will get here in the upper limit. So infinity plus 1 is nothing but infinity. So therefore directly I have taken integration of 1 to infinity f of x into dx, which is less than equals to limit as n tends to infinity Sn. And this I can say that, call it as equation 2. Right? Now I can verify, I can judge the given series, how it will turn to convergent and divergent, because we have converted the given series in terms of n plus 1th partial sum as well as nth partial sum. So in the case 1, so case 1 is what? Case 1 is what? If I assume, suppose this I is equals to improper integral, integration over 1 to infinity f of x into dx converges. See, if you assume integration over 1 to infinity f of x into dx converges. ಸೊ ಇದು ಕಾನ್ವರ್ಜೆನ್ಸ್ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿದರೆ ನಾವೇನಂತೆ ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಸಮೇಷನ್ ಯು ಎನ್ ಈಸ್ ಆಲ್ಸೋ ಸಮೇಷನ್ ಓವರ್ ಎನ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು 1 to infinity ಯು ಎನ್ ಈಸ್ ಆಲ್ಸೋ ಕಾನ್ವರ್ಜೆಂಟ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಸೊ ಹೇಗೆ ಪ್ರೂವ್ ಮಾಡ್ತೀರಿ? ಲೆಟ್ ಅಸ್ see how they have proved it. See, if you assume integration over 1 to infinity f of x into dx converges aitandre, definitely will get finite value for this integral. Why? Because it is convergent. We have assumed convergent andre limit hengirtada, convergent andre limit hegirtada. Yes, obviously finite. So therefore we have taken it is finite, right? So therefore from equation 2, so what is our equation 2? This one is our equation 2, right? So therefore if I take limit as n tends to infinity Sn plus 1 minus un, which is less than equals to I is what here? Integration over 1 to infinity f of x into dx, right? So therefore limit as n tends to infinity Sn plus 1, right? So see why we have taken this u1 in the right side part, because it is nowhere concerned with this limit. Why? Because there is no n term in the u1, so therefore it is nowhere concerned with the limit. Only limit will be applied for this term Sn plus 1. So therefore if you operate plus u1 for this equation, we'll get this one, right? So after operating limit in this step, right side part inequality, what we got? I plus u1. I is finite, u1 is also finite, right? u1 is what? First term, u1 is also finite, so therefore it is finite, and hence Sn is convergent, and hence Sn is convergent. So therefore if Sn is convergent, its sequence of nth partial sum of the given series is convergent, then what I can say that? Yes, obviously summation un is convergent. Yes, very good. So in case 2, if you observe, so next what we need to do? We need to assume that improper integration over 1 to infinity f of x into dx is divergent. We need to assume, right? So therefore we have assumed as this improper integral is divergent. So after assuming the improper integral divergent, when you are going to say that the given function or the given limit, the given sequence is divergent, ಯಾವಾಗ ಹೇಳ್ತೀರಿ divergent ಅಂತ? If I got limit infinity or more than one limit, if I got, right? So therefore it is infinity. So infinity means, therefore from equation 2 we have limit as n tends to infinity Sn is greater than equals to this integral value, obviously. So therefore Sn diverges, and hence I can say that summation un is also divergent. So hence our conclusion is what? Summation integration over 1 to infinity f of x into dx and summation un are both converges or diverges together. Is that clear, everyone? Is that clear? Any doubt? Any doubt? See, if you have any doubt, you can ask me. Okay. Even I will share this video in the Google Classroom. Okay, already you have enrolled in the Google Classroom, I think, in the previous semester, right? So I will share this video. I will share this video in Google Classroom. Okay. So next we'll move on to the examples. How we need to solve the examples. How we need to apply the Cauchy's root test, sorry, integral test in this concept. So first of all, before going to solve the example, we need to concentrate on note. So first note. So these notes are very important while solving the problem. See here, if x is greater than equals to k, then summation un and integration over k to infinity f of x into dx converges or diverges together. So k is some positive constant, right? K is some positive constant over there, right? In place of 1, they have given k. Is that clear? So first case, first note is over. Second note. So this second note is very important while solving the problem. Since integration over 1 to n f of x into dx, I have taken it as in, right? In. And how we can apply, how we can solve this integral value, integration over 1 to infinity f of x into dx, limit as n tends to infinity, integration over 1 to infinity f of x into dx, as how we can solve this integral, limit as n tends to infinity, integration over 1 to n f of x into dx. And this I can write down, limit as n tends to infinity in. So you need to remember these two notes. So it will be helpful for solving the problems. Let us concentrate on examples. So discuss the convergence of the series. First one, summation over n is equals to 1 to infinity 1 divided by n square plus 1, right? So we'll concentrate on first example. Let us take un as, see what is the statement of Cauchy's integral test. First thing is, for x greater than 1, greater than equals to 1, f of x should be non-negative and monotonically decreasing. That you need to remember, right? First step is, whenever the example they will give, you need to verify. First thing, you need to verify whether x is greater than equals to 1 or not. Sorry, for x greater than equals to 1, first thing you need to check that for x greater than equals to 1, the given function f of x should be monotonically decreasing and it should be non-negative, means all the elements of the function f of x should be positive, right? So let us solve this example. Un is equals to 1 divided by n square plus 1, that means that is f of n, right? And we need to convert in terms of x. Wherever n is there, you just put x. So f of x is equals to, we will get 1 divided by x square plus 1. So now what we need to do, this step is very important, next step. Now what we need to do, for x greater than equals to 1, according to Cauchy's integral test statement, we need to check that, the given function, how it should be. For x greater than equals to 1, whether f of x is greater than equals to 0, that you need to check first, right? For x greater than equals to 1, f of x, this f of x must be greater than equals to 0. Check it out. ಈಗ x ವ್ಯಾಲ್ಯೂ ಗ್ರೇಟರ್ ದೆನ್ ಈಕ್ವಲ್ಸ್ ಟು 1 ಹಾಕೊಂತ ಹೋದರೆ ಏನು ಬರ್ತದೆ ನಮಗಿಲ್ಲಿ? 1 divided by 1 plus 1 ಅಂದರೆ ಏನು ಬರ್ತದೆ 1 divided by 2 ಬಂತು ಹೌದಾ ಸೊ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಈಗ ನೀವು ಏನು ಮಾಡಿರಿ 2 ಹಾಕ್ರಿ ಅಂದರೆ ಗ್ರೇಟರ್ ದೆನ್ ಹಾಕ್ಕೊಂತ ಹೋಗ್ಬೇಕಲ್ಲ ಗ್ರೇಟರ್ ದೆನ್ ಈಕ್ವಲ್ಸ್ ಟು 1 ಎಕ್ಸ್ ಈಕ್ವಲ್ಸ್ ಟು 2 ಹಾಕ್ರಿ ಏನು ಬರ್ತದ 1 divided by 5 ಬರ್ತದ ಎಸ್ ನೆಕ್ಸ್ಟ್ ಏನು ಬರ್ತದ 1 divided by 10 ಬರ್ತದ ನೆಕ್ಸ್ಟ್ ಏನು ಬರ್ತದ 1 divided by 17 ಬರ್ತದ yes very good so now tell me whether the elements of f of x are positive or negative very good so here f of x is greater than equals to 0 and it is monotonically decreasing or not you need to check that so 1 divided first term what we got 1 divided by 2 we got and next term what we got 1 divided by 5 we got next 1 divided by 10 next 1 divided by 17 see the terms this one is x1 and this is x2 and this is x3 so on right so according to monotonically decreasing sequence definition what thing we have xn plus 1 should be less than xn right so this x2 check it out whether x2 is greater than x1 yes can anybody tell me whether x2 is greater than x1 no because x2 is greater than x1 x1 is greater than x2 here right x1 is greater than x2 here so this one is x1 and this one is x2 so x2 is greater than x2 is less than x1 that means x1 is greater than x2 same thing x2 is greater than x3 x3 is greater than x4 it means what this is in the form of monotonically decreasing ಈಗ ನೆಕ್ಸ್ಟ್ ಫಸ್ಟ್ ಟರ್ಮ್ x1 ಇಲ್ಲೇನದ x1 1/2 ಅದ 1/2 1/5 ಕಿನ ಜಾಸ್ತಿ ಹೌದಾ ಸೊ ಲೈಕ್ ದ್ಯಾಟ್ 1/5 is bigger than 1/10 so therefore what I can say that this sequence is monotonically decreasing or I can say that this function is monotonically decreasing understood how we need to verify the given function x for x greater than equals to 1 f of x must be greater than 0 and it should be monotonically decreasing is that clear everyone so next step ಹೋಗಬೇಕು ಇದು ಟ್ರೂ ಇತ್ತಂದ್ರೆ ಮಾತ್ರ ನಾವು ಏನು ಅಪ್ಲೈ ಮಾಡ್ಬೋದು Cauchy's integral test I can apply so therefore in is equals to what is our in integration over 1 to n f of x into dx so take that integration over 1 to n f of x ಇದ್ದಲ್ಲಿ ಏನದ ನಮ್ಗೆ 1 divided by x square plus 1 so therefore dx divided by x square plus 1 so already we have integration of 1 divided by x square plus 1 is tan inverse x so tan inverse x we got and tan inverse n minus tan inverse 1 tan inverse n minus pi by 4 we got that to what in value but what we are going to find out integration over 1 to infinity improper integral ಕೊಟ್ಟಿದ್ದಾರೆ Cauchy's integral test ಅಲ್ಲಿ integration over 1 to infinity but what we have integration over 1 to n we have first step we need to find out integration over 1 to n after that you need to apply limit right so now integration over 1 to n we got right now we need to apply Cauchy's integral test no So here, according to Cauchy's integral test, we have integration over 1 to infinity f of x into dx. That is nothing but limit as n tends to infinity in. Second note. This is second note. Right? So in value what we have? Tan inverse n minus pi by 4. So apply the limit for this one. Put the value of in and apply the limit. What we got? In place of n, if you put infinity, what will get? Tan inverse infinity will get. Tan inverse infinity will get is equals to, what is the value of tan inverse infinity? -90°. Very good. So here pi by 2 will get. Right? So infinity is equals to tan pi by 2. Tan pi by 2. Tan pi by 2 value is infinity. So if you take in the left side part tan, it will be tan inverse. So tan inverse of infinity will be pi by 2. Pi by 2 is nothing but 90. So therefore, put the value pi by 2 minus pi by 4 already we have. So simplify it, we'll get pi by 4, and pi by 4 is finite. So therefore, I can say that integration of 1 to infinity f of x into dx is convergent, and hence by Cauchy's integral test, I can say that summation un is also convergent. Understood how to solve this kind of problems? Same procedure. First un ತಗೋಬೇಕು, un ತಗೊಂಡು n ಇದ್ದಲ್ಲಿ f of x is equals to ತಗೋಬೇಕು, f of x is equals to un ಅಂತ ತಗೋಬೇಕು. ಎಲ್ಲಿ n ಇರ್ತದ ಅಲ್ಲಿ x ಹಾಕಬೇಕು. ಓಕೆ, ಎಲ್ಲಿ n ಇರ್ತದ ಅಲ್ಲಿ x ಹಾಕಬೇಕು. f of x is equals to, you need to take, so after taking f of x is equals